Alright, how's everybody doing out there in Math Magic Land? It's Mr. Muscarella coming at you, and we're going to look at our third and final video in exponent rules called the quotient rule. So now, let's take a look at a quick example. We're going to look at these two guys and kind of go about this the long way. And then I think you will pick up a shortcut. So let's kind of analyze this. 2 to the 5th power means I'd have 2 times 2. I'd have 5 2's being multiplied together. 2 times 2 times 2, that's 3, 4, and 1 more. Now the denominator has 2 to the 3rd power, which means I would have 3 2's on it. 2 times 2 times 2. Now, we know from our earlier days in mathematics, every 2 on the top that matches with 1 on the bottom, they would cancel out because they would give you 1. So 2 divided by 2 is 1. There's another 2 and another 2. That's gone. And last but not least, we carry up and we end up with our third 2 canceled out. So we're done, and all we have left with is 2 times 2, which is the same thing because my base is 2, so I'm going to have 2 squared. Let's see if we analyze the pattern here. Now 3 to the 5th power, so I'm going to have 1, 2, 3, 4, 5, and the numerator, and then the denominator, I'm going to have a base of 3, but I'm going to have 8 of them. 1, 2, oops, I was going to write an 8 because I've got so many of them. 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6, 7, and 1 more gives me 8. All right, so I got to make that a little bit longer. Holy moly. Now, look at all these 3's that can cancel out. So that one's gone, 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 that one's gone. Finally, that one's gone, and there I am. Wow. Holy moly, that's a lot of 3's. We did a lot of work there. Now we got to clean this up a little bit more. Now on the top, everything canceled out. So what number do we write on the top if everything cancels out? Please don't say 0. Yes, that's right. The correct answer is 1. Everything's gone. So all I have is 1 in the numerator. Now in the denominator, I've got 1, 2, 3 3's. So my base is 3. I've got 3 3's, so I would write that as 1 over 3 cubed. Wow, that's all you have to do? Now, what's the pattern here? So I want to see if you can pick up a pattern with the exponents here. So I have a 5 and a 3. My base is 2, so I keep my base the same. Look at that. My exponent's a 2. And my base is a 2. Now here, second example, I've got exponents of 5 and 8, 5 in the numerator and 8 in the denominator, both with a base of 3. Now if I keep my base the same, notice, how do you end up with that? Maybe there's a pattern there that involves a simple operation in mathematics. One of the 4 basic operations that we learn early on called subtraction. That's right. 5 minus 3 gives us 2. Look, there's my exponent of 2. Now, if I do 5 minus 8, or 8 minus 5, actually, 8 minus 5 is 3. But since the 8 is bigger than 5, then we would put our exponent in the denominator, not in the numerator. All right, because on this other one, it's like everything cancels out and it's over 1 and over 1. But, you know, math people, we lazy, so we don't write an over 1 thing. We're just like, yeah, that's good, man. You can just write that as 2 to the 2nd power. We good. But you can't do that. If everything cancels out in the top, you have to write a 1. All right, now that we got that out of the way, let's take a look at a few examples. 2 to the 11th over 2 to the 6th. Okay, so here we go. We're going to take our exponent of 11 and 6. So we're going to go ahead. Now let's do this mentally. 2 to the 11 minus 6. Whoa, 11 minus 6 is, of course, 5. Now some people may be able to skip that intermediate step because you're a rock star like that. So good for you. Now in the second one, be really careful here because you have the number -4. -4 is being raised to the 7th power and the 4th power. So anytime you have a negative integer, make sure that you put these brackets around it, these soft brackets, the parentheses, because if you don't, and I know we run into this all the time, like if you write -2 squared and type that in your calculator, you're going to get an answer like this. But if you have this, -2 squared, of course we know -2 times -2 gives us +4. So yes, the parentheses matter. So don't be lazy and make sure you write those. Thank you. So let's see, we had -4 to the 7 minus 4, of course, 7 minus 4 gives us 3. So -4 with our parentheses, because no parentheses, no point for you. -4 to the 3rd power. And then on this one here, we have x to the 5th over x cubed, and I'm sure you can probably do that one mentally now. X to the 5th over x cubed would give you x to the 2nd power. Boom, shazam, we done with that junk. Now, let's get into 3 other problems for you. Here's the first one. 3 y to the 11th over y to the 5th. Now, with the 3 and the 12, all right, what we've got to take a look at with these guys is we want to analyze those and say, okay, if I were to take 3 over 12, can I reduce that? Well, of course I can, because 3 goes into both of those. So 3 goes into 3 once, and 3 goes into 12 4 times. So that constant that's out in front would end up being just 1 in the top, or a 4 in the denominator. Now, my exponents, I've got 11 and 5, so when I subtract those, when we do subtract 11, take away 5, I end up with y to the 6th power. Now, in math, we usually don't write a 1 out in front if we've got other stuff there. So you would want to clean that up and write that as y to the 6th power over 4. All right, because 4 is a cosmic number. All right, cool. That's it for that one. All right, just take your time and see if there's anything you can reduce. And if you can, reduce any constants. Now here on this one, we've got x to the 9th, y to the 4th, z to the 5th. So let's take a look. Ooh, we got that 6 and that 2. Well, we know 6 divided by 2, of course, is 3. So we would have 3 in the numerator. Now, x to the 9th, and I've got an x in the bottom. Whoa, what is going on with that? I got a 9, and I don't have anything there? Oh, but that's right. We're cool. We're rock stars. We know the exponent there is 1. So 9 take away 1? Yeah, that's 8. You're great. So I'd have x to the 8th power in the numerator. Now, my next term, I've got y to the 4th and y squared. All right. 4 minus 2 gives me 2, so we would have a y squared in the numerator. And then lastly, z to the 5th and z4, so z5th and z4. When I subtract those, I'm going to end up getting just a plain old z, and we're not going to write z to the 1st power because we don't need to write a 1 for an exponent. And then everything on the bottom is gone. Oh, cool. So we don't even have to write this like fraction bar. We're done with that. Yeah, goodbye. We don't need to write you. So our final answer then would just be 3x to the 8th power, y to the 2nd power, and then just a z. Cool. Not bad. Now here's one more for you to try on your own. If you think you got it, pause. And then come back and check it out. See how you did. All right, let's see how we do. Let's go through this one step by step. Inch by inch, it'll be a cinch. So 5 goes into 15, so 5 goes into 15 3 times, all right? So I'm going to numerator, I'm going to have a 1, and then in the denominator, I'm going to have a 3. Now, for my x's, I've got x9, 2. So when I subtract those, 9 minus 2 is what number? 9 minus 2, 7. So since 9 is bigger than 2, we will have x, we would have x to the 7th power. And then my y's, when I look at the y, I have y to the 4th and y 12. So I'm going to subtract again. 12 minus 4 is 8. But since my denominator has a higher exponent, I would have my y's to the 8th power in my denominator. And likewise, when I take a look at the z exponent, I have z to the 5th and z to the 14th. So 14 minus 5 gives me 9. But 14 is bigger than 5, so z gets written in the bottom. So z to the 9th power is in the bottom. So again, you don't have to write the 1. So you could just write it as x to the 7th over 3 y to the 8th, and then z to the 9th. All right, that would be your final answer for simplifying this problem using the quotient rule. All right, that's it for this video. Thank you guys for watching. I will catch up with you later. Have a great day. Peace out.